What's up, guys? In this video, we're going to work on how to simplify a complex fraction when you have a fraction over a fraction. So basically, we're taking a rational expression and dividing it by another rational expression. Now, we're going to go ahead and do that by working through 5 different examples, as well as identifying values that are not going to be in the domain of the expression. I hope you enjoy. So what we're going to do is look at this is simplifying our complex fractions. So we're going to go off all the knowledge that we've had about simplifying rational expressions and then also dividing rational expression in this case. Now, what we see here is we have a rational expression being divided by an integer. All right, I'll actually use a different thing. So what we're going to do is when dividing this, what we want to do is kind of rewrite this as a fraction. So I'm going to rewrite the 3 as 3 over 1. Okay, so now you can see what it is a rational expression divided by another rational expression. This one just has integers. So therefore, what we can do is we can rewrite this problem as being multiplied by the reciprocal. So what we're trying to do, the reason why, again, why we multiply by the reciprocal is if I want to get this fraction off the bottom and I only want to deal with one fraction, I'm going to have to multiply by the reciprocal. Now remember, to keep equivalent fractions, whenever I multiply in the denominator, I have to multiply in the numerator. So now what I have is a problem of 2 divided by x plus y times 1/3. Well, when we multiply fractions, we just multiply directly across. Therefore, I have 2 over 3 times x plus y. And there you go, ladies and gentlemen. That's how you simplify your complex fraction. Thanks. OK, so on a problem like this, there is actually a shortcut we could go through. And I could say that the answer is just going to be 2/5. Because when we have the same term in the numerator and the same term in denominator being divided by the same value, we know that's going to undo itself. So I know the answer right now is 2/5, but let me show you how I know that's going to be 2/5. So let's just kind of go back to what we've been dealing with before. When we have a fraction in the denominator or a fraction in the numerator, a couple things, we just want to multiply by your reciprocal, right? So we could always multiply by the reciprocal of this would be x plus y over 5 times x plus y over 5. Well, we know that any fraction multiplied by its reciprocal, we know that multiplies out to 1. Here, since we only have multiplication, we're going across multiplication, we know that x plus y will divide out with x plus y, so we're just left with 2/5. Another way we could do this is you don't even need to multiply by the reciprocal. If I just multiply by x plus y on both sides, we still know, if I just multiply by x plus y over 1, because that's the LCD of our numerator and of our denominator, we're still going to have that's going to divide out to 1, and that will still divide out to 1, leaving us with 2/5. So there's a couple ways that you can go through it. And again, what we've now had, we still have a fraction, but it's not going to be a complex fraction. So therefore, that's going to be our final answer, 2/5. Hope you enjoyed. Thanks. So in this example, as I mentioned, guys, whenever you have a fraction divided by another fraction, the main important thing is to multiply by the reciprocal. Because what's nice about that, if you were to kind of put these in parentheses here, you guys can see that each of these are now separated by multiplication, right? You guys see each of these quantities are separated by multiplication? Therefore, we can apply that division property I just spent 5 minutes explaining. So now, multiplying a fraction by its reciprocal, doesn't matter how crazy the fractions look, is automatically going to equal 1. So now, however, now our denominator is equal 1. But remember, to keep equivalent fractions, if you had the fraction 4 over 5, and you just multiply the denominator by 2, you now have 4 over 10. Those are not equal to each other. But if you have 4 over 5, and you multiply by 2 over 2, you get 8 over 10. Do you guys agree with me that 4 over 5 is equivalent to 8 over 10? Yes. So whatever you multiply in your denominator to produce equivalent fractions, you have to multiply in your numerator. So basically, for your complex fractions, you're just going to multiply by the denominator's reciprocal in the numerator and the denominator. Now, over here, the problem with this is these look very similar to each other, right? Yes. They're almost the same, but they're not. So, but one thing I could do is this is negative, that's negative. That's positive, that's negative. I could always factor out a negative, which would make that a negative. Actually, let's do that in black. If I factored out a negative here, that would turn that to negative and that to positive. Would you guys now agree that those two are the same? What do you mean, sure? negative x, positive y, positive y. They're just flip-flopped around. Yes? I'm just factoring out. I'm not changing the value of anything. For instance, if I had the example x plus 3, right? And let's say I factor out a negative. When I factor out a negative, that makes that negative, and that makes that negative. Do you agree with me that negative times negative x and negative times negative 3 is the same thing as positive x plus 3? It's the same thing. So factoring is not changing the value. It's just rewriting it in a different format. Does that make sense? So since I factor out the negative, notice, negative times negative x is that's still equal to positive x. Negative times positive y is still equal to negative y. So I didn't change the value. By multiplying by the reciprocal, I changed the value, right? That's why I had to do that on top and bottom. But factoring, I didn't change the value. I just changed the form, so now I could apply the division property. Just remember, though, there is a negative 1 there, though, still. All right? Then we can use our rules of exponents. 6x squared divided by x cubed. X squareds will divide out. That will leave me with a 1 on the bottom. So my final answer is going to be a 6 over negative x. And we can just write the negative out in front. Anybody have any other questions on that? No? OK, so now, ladies and gentlemen, let's take a look at a problem like this. Kind of similar to the one that we had, but it's also written a little bit differently, right? But all I want you guys to really understand with this is saying this fraction divided by that fraction, right? It's really just saying x squared divided by x squared minus y squared divided by 4x divided by y minus x. Isn't that the same thing? Yes? Isn't this big fraction bar mean division? Yes. So if you have a problem that's written like this, you can treat it as dividing a fraction. And then what do we know about division? When I have two fractions to divide, we need to multiply by the reciprocal. So now in this problem I have x squared divided by x squared minus y squared. And remember, we're always flipping the divisor times y minus x divided by 4x. Okay? So now, ladies and gentlemen, we need to go back and see how we can simplify this. So what I have here is x squared. I could write this as x times x, but I don't think you guys need that. X squared minus y squared is a difference of two squares, which is x minus y times x plus y, times y minus x divided by 4x. So now let's go and look at this and see what can we cancel, what can we divide out to 1. All right? Well, we obviously know x squared can be divided by x, right? We can lose an x. Yes? So now this becomes x to the first power, and the x's divide out to 1, right? Because this is really x times x, right? X squared is x times x, so the 1 x's divide out. I'm not going to accept this if you're not going to be going through this, okay? So please put that back away. So, because you have an opportunity for 2. Now the next thing is, can I divide y minus x with one of these terms for it to get to 1? Can I? Can I? No, right? These are not exactly the same. However, what about, ladies and gentlemen, if I factor out a negative 1? If I have y minus x, and now what I do, Ronnie, because you're really going to want to make sure you guys understand this and pay attention to this. If I have y minus x, if I factor out a negative y, or negative 1, it now turns to this. If I rewrite this as x minus y, is it now like one of those factors down there? Yes. So what I'm going to do, ladies and gentlemen, is I'm going to factor out a negative 1. That becomes a negative. That becomes a positive. Now, that is exactly the same as that term. So they now cancel, or they now divide up to 1. Huh?
So you have to show that side
No, that's just for me to explain to you guys where it came from. So now, instead of having an x, we have x times -1. So my final answer is going to be a negative x divided by 4 times x plus y. And that would be your final simplified version. So just to go back and review, if you have a fraction divided by another fraction, rewrite it as your division, rewrite it by flipping, and rewrite as a multiplication. Try to cancel out, try to divide out what you can. If you can't divide out, always look into factoring out a -1 to simplify it even further. Okay? So the main important thing is that it's a complex fraction. The first thing you're going to want to do for every single example you guys do is simplify. Look at every numerator and denominator of each fraction and simplify it. Well, 4x I cannot simplify any further. Nor can I simplify x plus 6. However, x squared minus 3x, I do notice that those have an x in common. So I'm going to factor out an x. Does everybody follow me with that? Factor out an x. And then in my bottom, in my denominator of my denominator, I'm going to factor this in my head because I told you we're going to start moving quicker. Yes?
Isn't it 3x?
We're like here? I factor out the x, so you can always check your work. If you apply distributive property, x times x gives you x squared. X times -3 will give you -3x. Got it? So now in this one, though, I'm going to factor using the tree, which we already did that other distributive property. I'm not going to spend time going through that method again. If you need help with that, come and see me. This could be factored into x plus 6, x minus 3. Basically, what I did was I said, what two numbers multiply to give me -18, and then add to give me a +3. That's how I came up with that. Now, basically, what I try to reiterate for everybody is whenever you're trying to get a fraction off the denominator, the best thing to do is multiply by its reciprocal. So I'm going to multiply by x minus 3 times x plus 6. X times x minus 3. The reason why multiplying by its reciprocal works is that division property. You guys notice that the division property you can see that the x minus 3 and the x minus 3 divides to 1. X minus 3 and x minus 3 divides to 1. X plus 6 and x plus 6 divides to 1. And the x divides times 1. So anytime you have a rational function or a fraction in the denominator, yes, question? I multiplied the blue by its reciprocal. So I put the denominator in the numerator, and I put the numerator in the denominator. Anytime you have, the reciprocal of 1/4 is 4/1. All I did was flip them and multiply them. But what's nice is multiplying them, since every single expression, do you guys see how all of these are separated by multiplication? They're all separated by multiplication. Each expression is separated by multiplication. So that's why I could cross out or basically divide to 1, right? However, though, whatever you do in the denominator, ladies and gentlemen, you have to do in the numerator to produce equivalent fractions. You just can't take 4/5 and just multiply the bottom by 2. That's 4/10. That's not the same. But if you did 4/5 and multiplied by 2/2, then you'd have 8/10, which is the same thing as 4/5. Do you guys see that? So I have to multiply by my reciprocal, x minus 3 times x plus 6 over x times x minus 3. And what you guys can see when I now go ahead and do that, they both had an x minus 6. OK, you could have simplified that before, but whatever. Now you can see that by applying the division property, the x plus 6's divide to 1. The x minus 3's I could have divided earlier, but they are going to divide to 1. And the x over the x divides to 1. Leave me with a final answer of 4. Got them?